Ruchit, unmute yourself and tell me the screen is visible and audible.
Yes, sir.
Good morning, everybody. Last class we discussed about.
Good morning, sir.
Hele. Hello.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Very good morning. Mute yourself. Shall I start?
Yes, sir.
Last class we discussed about the type of metals. The metals are classified into two. The broad classification. One is iron. Broad classification is ferrous and non-ferrous. In the ferrous metals, the broad classification iron and steel. In iron, you have cast iron, pig iron, wrought iron. In steel, carbon steel, alloy steel, tool steel. Again, you have sub-classification. Cast irons are classified into gray cast iron, white cast iron, malleable cast iron, ductile iron. Carbon steels, as we are using the tools in our house and in the industry and in the machine shop, in the workshop, wherever you use the tools that are manufactured from low carbon steel. And some of the tools, for example, hammer, chisel, and other items which we use in our house or in the industry, that's made from medium carbon or high carbon steel. And all of you seen the anvil in the workshop, that is made from high carbon steel. And alloy steel, tool steel, like this. This is the broad classification of ferrous metals. And we already studied the engineering materials that's classified into metals and alloys and non-metals and the properties of metals. So we discussed 5 properties yesterday. I start from number 6, the brittleness. All of you seen what is the property of brittleness? What actually it is? That is nothing but the property of the material that is exactly opposite to the ductility. Ductility is the enablement to make the wire. But if the metal has brittleness, then you cannot draw or you cannot pull the metal. If you drop that, there will be a crack or break. So the brittleness is the property of the materials. You cannot observe or cannot see the ductility. That is nothing but breaking of material. For that, a good example, cast iron, bronze, and concrete. These 3 are good example for brittleness. Now you write down number 6, brittleness. Line that. Put a colon and hyphen. Brittleness is the property of the material. Brittleness is the property of the material opposite to the ductility. Opposite to the ductility. Full stop. It is the property of breaking the material. Breaking the material with a little permanent distortion. Permanent distortion. Next line write down example. Example, cast iron, comma, bronze, concrete, etc. Next line write down number 7, malleability. Malleability. All of you have almirahs in your house. Almirah, which is made from Godrej company or the almirah made in the local industry. Say there will be 2 types of sheets are available. The one is produced in the hot condition. that is called hot rolled sheet, and one is which is produced from in the room temperature. It is called cold rolled sheets. The cold rolled sheets are costly, hot rolled sheets are cheaper, because in the cold rolled sheets you observe strain hardening of the material. That is, if you press the metal, the atoms and the bond between the atoms are squeezed, compressed. For that reason, you have the property corrosion resistance in the cold rolled sheet. For that reason, it is called, for that reason, the cost of the cold rolled sheets are very, very high. Say, today itself, you see the backside of Almera in your house. If there will be a scratch, you can see the color of the scratch. That's in red color. There is nothing but the iron oxide. There is the rust formed in the backside. Suppose you have Almera made by Godrej company. You see that if there will be a scratch in the backside, there is no corrosion in the sheet, because the sheet is manufactured from cold rolled process. The malleability is the property of the material that can be drawn into thin sheets. Thin sheets. Usually mild steel, copper, aluminum are easily drawn into the sheets. Now write down number 7, malleability. Underline that, put a colon and hyphen. Malleability is a property of a material, enabling it to be drawn into thin sheets. Next line, write down example. Mild steel, copper, aluminum, lead, etc. Next, write down the property number 8, toughness. Write down number 8, toughness. Underline that, put a colon and hyphen. Toughness is the property of a material to resist fracture due to high impact loads or hammer blows. Say, if you hammer a component which is made from brittle material or ductile metal or any metal, if you observe the fracture, then you can say that the metal has less toughness. If it resists the hammer blows or impact load, then the toughness of the material is high. Next, you write down number 9, resilience. Underline that, put a colon and hyphen. Say, for civil engineers or mechanical engineer or whether the computer science engineer, tell me why the rubber bushes are provided in the bottom of the printer. One thing. Next, bottom of the monitor. Next, the bottom of the mixie you have in your kitchen, and rubber bushes are provided to the washing machine, wet grinder in the bottom. Why they are provided the rubber material bushes? Say, yesterday we discussed about elastic limit and the plastic limit. The elastic limit is if you remove the load or if you remove the force, the component regain its shape and size after removing the load. If you again load the specimen, again the compression or elongation takes place. That is nothing but the elasticity of the material. The resilience is the property of the material to absorb energy and resist a shock and impact loads. Nowadays, you might have seen the metro train and the bridge, the pillar of the bridge and the road. In between that, they place some rubber material. When the train passes the bridge, that rubber material compresses. After leaving that place, again it comes back to its original normal equilibrium position. That is nothing but when you apply the load on the specimen or the material, which absorbs the energy. When you remove the load on the material, again it comes back to its normal equilibrium position. This is known as resilience. This is known as resilience. Write down number 9, resilience. Underline that, put a colon and hyphen. Resilience is the property of a material. Resilience is the property of a material to absorb energy, and to resist shock and vibration. Full stop. Resilience is measured by the amount of energy absorbed per unit volume within elastic limit. This property is essential. For spring and rubber materials. Next property, number 10, creep. Say the tension test, compression test, shear test, torsion test, all tests are conducted on the specimen. All tests are conducted in the basic material testing lab using universal testing machine on the specimen. Creep is nothing but the test is conducted on the live specimen. Remember, the live specimen, whether it may be a pillar, whether it may be a beam, whether it may be a shaft, the test is conducted on live, real material. Now you write down creep, underline that, put a colon hyphen. The creep test may take time. This is, listen properly, this is very, very important. The creep test conducted on the real or live components. The test may take 1 hour, 1 day, 1 week, 1 month, 1 year, or 10 years, or even more. The creep test take more than 1 year or 10 years or even more years. So from this concept only, they calculate the life of the component, life of the machine, life of the machine tool, life of the automobile. When you want to purchase something, like for example, if you want to purchase the TV for your house, first word you ask the dealer, what is the warranty and guarantee. Warranty means if there any manufacturing defect is present in the component, they have to repair or they have to replace the item. The guarantee and warranty are calculated from the creep test. Creep test. Underline that, put a colon and hyphen. When a component is subjected to constant stress at high temperature for a long period of time, comma, it will undergo a slow and permanent deformation called creep. Next line, write down. The creep test may take 1 hour, 1 week, 1 month, 1 year, 10 years, and even 25 years. 25 years. Full stop. Results of the test are used for the calculation of life of the component. Next, write down number 11. Fatigue. Underline that, put a colon and hyphen. Fatigue is the repeated loading of the component. Or cycling loading of the component. And the component is loaded cyclically or repeated load on the component. Is it possible to withstand the load or not? The fatigue. Say, for example, I ask you to walk in one direction for 25 meters. All of a sudden, I ask you to change the direction of walking in the opposite direction. You feel little fatigue or you feel difficulty in walking in the opposite direction? That is nothing but fatigue. Underline that, put a colon and hyphen. When a material is subjected to repeated stresses or cycling loading, it fails at stresses below the yield point stresses. Full stop. Such type of failure of material is known as fatigue. Is known as fatigue. Next, you write down number 12, hardness. Underline that. Hyphen. Hardness is the property. All of you observe. You have two metals. One is aluminum, other one is cast iron. Which one is harder? Cast iron is harder. By observing the metal, by testing or scratching on the surface, you feel easiness, then you say the hardness is less. You feel difficulty on scratching on the surface, then you say the hardness is more. So write down, hardness is a property of a metal. Property of a metal, and resistance to wear, scratching, deformation, and machinability. Say, suppose in lead, if you remove the metal easily, then you feel that the metal is soft. If you feel little difficulty of removing the metal, then you say the metal is hard. That is machinability, etc. So here you have 12 mechanical properties of the material. You may have the question like this in the examination. Write down the question. Define the following mechanical properties. Mechanical properties. Usually, you have this question for 3 marks or 5 marks. Suppose you have this question for 5 marks, you have to write minimum 10 properties. Suppose you have this question for 3 marks, explain and define only 3. So this is the table. In this table, you can go through the composition, properties, and application. This is one method of explaining different types of metals. After completion of this module, I will give you this table and go through this. Next, you write down ferrous alloys. Ferrous alloys. Underline that. In Latin, iron is known as ferrum. In Latin, iron is known as ferrum, and its chemical designation is Fe. Fe, full stop. Next paragraph, write down. Ferrous metals are basically iron-based metals. Iron-based metals or contain iron as their main constituent. With some allying elements like chromium, tungsten, nickel, vanadium, silica, manganese, manganese, phosphorus, sulfur, etc. etc. Next paragraph, write down. Ferrous alloys are classified into. Write down number one. Write down number one. Cast iron in bracket. Write down containing greater than 2% of carbon. Greater than 2% of carbon. Next line, write down. Number two, steel containing less than 2% of carbon. Less than 2% of carbon. Next, write down. Write it fast. Classification of ferrous alloys. Classification of ferrous alloys. Write it fast. Number one, cast iron containing greater than 2% of carbon. Close the bracket. Write down subdivisions one by one. Subdivision A, grey cast iron. Here I made a mistake. Grey, Grey. Grey cast iron. Subdivision B, malleable cast iron. Yesterday I told you the ST iron or nodular iron. All of you see that all of you consume the nodules. The same type of structure is present in the iron. It is called nodular iron or ST iron or ductile iron. Subdivision C, write down nodular iron or SG iron or ductile iron. Next line, write down subdivision D, white cast iron. White cast iron. Subdivision E, you leave chilled cast iron and molten cast iron. No need these two. You write down E, alloy cast iron. Alloy cast iron. Next, you write down number two, classification number two, steel in bracket, write down containing less than 2% of carbon. Subdivision A, plain carbon steel. Yesterday, I discussed and explained about the carbon steel. Again, subdivision number one, low carbon steel. Subdivision number two, medium carbon steel. And subdivision three, high carbon steel. Next, you write down alloy steels. In alloy steel, write down any five. In the examination, you have to write any five. No need to write all the 9. You write down alloy steel. First, silica steel. Next, subdivision number 2, nickel steel. Next, you write down subdivision number 3, chromium, nickel steel. Right, number 5, stainless steel. Stainless steel. In alloy steel, minimum 5 is required. 5 is enough. Next, first you write down grey cast iron. Grey cast iron. Underline that. Write down first number 1, composition. Composition. Grey cast iron. Underline that. First number 1, composition. The grey cast iron has 2.5 to 4% carbon, 1 to 3% silica, 0.4 to 1.5% manganese, 0.06 to 1%, 0.1% sulfur, 0.1 to 0.2% of phosphorus, remaining iron. Remaining iron. In the examination, first you write First, you have to write composition, the particular metal, what all the constituents. Grey cast iron, carbon, silica, manganese, sulfur, phosphorus, remaining iron or rust iron. Next line, write down, next paragraph. Number 2, properties. Number 2, properties. Write down one by one. High fluidity. Say in the liquid condition, you can fill the mold cavity. All the intricate shapes and intricate castings can be produced if the metal has the high fluidity. Number 1, high fluidity. Number 2, low shrinkage during solidification. Remember, the metal is in liquid condition. The volume of the metal, liquid metal, is more. When the phase changes from liquid to solid, there will be a volume contraction. Volume contraction. For that reason, the mold cavity in the foundry is prepared a little bit larger than the required size. That is volume shrinkage. That volume shrinkage should be less. For that reason, item number 2, low shrinkage during solidification. Low shrinkage during solidification. Next line, write down number 3. The strength of the component should be more when it is made from cast iron. The compressive strength, very high compressive strength. Number 3. Write down number 4. Very effective in damping vibrations. Very effective in damping vibrations. Say, if the base of the machine tool or bed of the lathe or bed of the any machine made from cast iron, the vibration should be very, very less, because the metal cutting action produces very high vibration. The metal should have effective vibration resistance. That is nothing but very effective in damping vibrations. Next, number 5, good wear resistance. If the metal contact takes place, the resistance of the metal should be very, very high. There should not be any erosion or sliding of the metal should not take place. Next, number 6, excellent machinability. Say, the component can be machined any shape, any size, and any dimension. That property is nothing but excellent machinability. Next, this is the main property we expect in all the metals, that is good corrosion resistance. Good corrosion resistance. In atmosphere, in the humidity, we have the moisture content. In the 50% of humidity, there will be more moisture content. The reaction takes place between the surface of the component and the moisture and produces the oxide of the metal on the surface. So for that reason, the corrosion resistance is very, very important. Next, you write down number 3, applications. Number 3, applications. Write in the paragraph type or write one by one. First application, number 1, used in pressure vessels. All of you say nowadays the oxygen container transported from the foreign countries to India and some of the states to Karnataka, and the containers, that's nothing but the pressure vessel. Pressure vessel. The pressure vessels are made from grey cast iron. Number 1, used in pressure vessels. Next line, write down number 2, cylinder heads of the engine, cylinder heads and blocks of the IC engine. All of you write down cylinder heads and block of the IC engine. Next line, write down. Number 3, clutch plates and pistons of the automobile. Next line, number 5, bed and base of the machine tool. Bed and base of the machine tool. Next line, write down. Heavy duty equipments. Heavy duty equipments. All of you seen JCB, crane, lifts. They are all heavy duty equipments. Say for any metal, whether it is gray cast iron, white cast iron, malleable cast iron, or nodular cast iron, first you have to write the composition. What are the constituents present? Next, number 2, properties. Number 3, applications. Like you have to write any 5 metals in the examination, whether it is the ferrous or non-ferrous. Next, come to the point. Write down malleable cast iron. Malleable cast iron, which contains 2.5 to 2.6% carbon. Next, 1 to 1.4% silica, 0.4 to 0.8% manganese, less than 1% sulfur, less than 1% phosphorus, and remaining iron, and the rest iron. And you have properties here. Say after completion of this topic, you can make 5 or 6 common properties and common applications. First, number 1, write down composition. Number 2, properties. Number 3, application. Lakshmi? Yaar bell hodre? Sairaj? Hello, hospital. Write down composition. Next, number 2, properties. Number 3, applications. Malleable cast iron. So you have number of applications, you have number of properties, and clearly write the composition. Write down malleable cast iron. Next, you come to the point, spheroidal graphite iron. Spheroidal graphite iron. In bracket, write down SG iron. SG iron. This is a very, very important for engineers because we expect long life in the components, and if the component is made from spheroidal graphite iron, then you have more life. This is very, very important. Mark it, all of you. Very, very important. Number 1, write down composition. 3.2 to 4% carbon, 1.8 to 3% silica, 0.25 to 0.5% manganese, 0.08 to 0.08% of maximum sulfur, 0.01% maximum phosphorus, and remaining iron or rest iron. And here all of you observe here, the lot of properties are present. You remember any 5 or 6 properties in the examination, write any 5 or 6 properties. The metal is ductile, impact strength, corrosion resistance, wear resistance, machinability, and other properties. So after completion of this topic, you make the common 5 or 6 properties and common applications of 6 to 7 applications. Write down spheroidal graphite iron, SG iron. Next, come to the point, low carbon steels. Low carbon steel. Low carbon steel. Write down up to 0.25% carbon, up to 0.25% carbon, comma, write down, see, the carbon percentage is less, 0.25%, for that reason it is called low carbon steel. Next you write down carbon, only the name enough, carbon, chromium, tungsten, molybdenum, vanadium, nickel, and remaining iron. Remaining iron. Next you write down properties. Number 2, properties. The property of the material. See, all of you observe here, the metal is soft, ductile, tough, has good machinability, weldability, and hardenability. You make the 6 common properties for all the metals and applications used in automobiles, structural shapes, building, bridges. Like number 1, composition. Number 2, properties. Number 3, applications. Next you write down medium carbon steel. Medium carbon steel. First, number 1, composition from 0.25 to 0.55% carbon. 55% carbon. Chromium. Please, all of you come to the low carbon steel. Here you have chromium, tungsten, vanadium, molybdenum, nickel. In bracket, write down. In bracket, write down all the allying elements. All the allying elements present in 2 to 8%. 2 to 8%. All the allying elements present in 2 to 8%. Close the bracket. Close the bracket. Next, medium carbon steel, which has the medium percentage of carbon, that is ranges from 0.25 to 0.55% carbon, comma, chromium, tungsten, molybdenum, vanadium, nickel. In bracket, write down all the allying elements. All the allying elements present in medium carbon steel, in medium carbon steel, which ranges from 2 to 12%. 2 to 12%, and remaining iron. Next, write down number 2 properties. The medium carbon steel are very, very tough and strong. Next, write down number 3 applications used in railway, wheels, tracks, components, gears, and crankshafts. Next, come to the point. High carbon steel. Write down the word high carbon steel. Underline that. Number 1, composition. Number 1, which has from 0.55 to up to 2.1% carbon. 2.1% carbon. Chromium, tungsten, vanadium, molybdenum, nickel are present. In bracket, write down 2 to 18%. 2 to 18%. Close the bracket. Next, properties. Number 2, properties. High carbon steel are very, very tough, hard, and used in manufacturing of tools. All of you observe here. The knives, razors, scissors, blades, and single point cutting tools used in the machine tools. Application. That's number 3, application. Now I stop at this stage. I will continue in the next class. Now all of you, please write your name and USN in the chat box. All of you unmute yourself and answer roll call. Answer roll call. Unmute yourself. Varshita. Pooja R.
Present, sir.
Suchitra.
Present, sir.
Vachana.
Present, sir.
Swati.
Present, sir.
Tanmay.
Present, sir.
Vanyashri.
Present, sir.
Jason.
Present, sir. Jason, sir.
Hey, here you mentioned JASON. Jason or
You
Jason
should
it
pronounce
is.
it as Jason, sir.
Okay.
Jason, sir.
Okay, next Sanjana.
Present, sir.
Shreya.
Present, sir.
Amruta.
Present, sir.
Yashaswini.
Present, sir.
Krupa.
Present, sir.
Kushi.
Present, sir.
Vibha.
Present, sir.
Vinayaka.
Present, sir.
Trijan. Danyata.
Present, sir.
Vinayashri.
Present, sir.
Sakshi.
Present, sir.
Samarth.
Present, sir.
Bhaganagowda.
Present, sir.
Syed.
Present, sir.
Siri.
Present, sir.
Vaishnavi.
Present, sir.
Shravya.
Present, sir.
Deepti.
Present, sir.
Prajna.
Present, sir.
Suhas.
Present, sir.
Mohammed Shahil.
Present, sir.
Ruchita.
Present, sir.
Pratik.
Present, sir.
Sufyan Khan.
Present, sir.
Manikya.
Present, sir.
Sri Om.
Present, sir.
Shivansh.
Present, sir.
Manya.
Present, sir.
Jason.
Present, sir.
Junaid.
Present, sir.
Sandeep,
Sir, am I audible?
Absent.
Present, sir.
Vishwas,
Present, sir.
Sanjana KJ,
Present, sir.
Sanjana TR,
Present, sir.
Anushri,
Present, sir.
Vandana,
Present, sir.
Pratik CR,
Present, sir.
Vijendra,
Present, sir.
Yes, sir.
Shreya,
Present, sir.
Rukmini,
Present, sir.
Deepthi, Sandeep,
Yes, sir. Present, sir.
Vineet,
Present, sir.
Sneha,
Present, sir.
Rukmini.
Present, sir.
Why you are writing twice or thrice your name? Write only once. The jumps will not consider your if you write twice or thrice. You write only once. If you write twice, tomorrow onwards, I will put absent. Varsha, see you.
Present, sir.
Varshita HG.
Present, sir.
Shraddha.
Present, sir.
Zikriya.
Present, sir.
Yatindra.
Present, sir.
Banushri.
Present, sir.
Manoj.
Present, sir.
Listen properly. If you miss the attendance, end of the
Yes,
attendance.
sir.
Wait, man.
Sir.
End of the attendance, I will give you chance to tell the attendance. Now you tell me your name.
Kushal Kayan.
Okay, Kushal Ken. Okay, next. Anybody else? Anybody
sir.
else? Okay. Now I stop at stage. I will continue in the next class.
Bye, sir.
Bye, sir.